Okay, sir, you can start now.
Okay, sir. Sorry, guys, for the technical issue. Let's get starting with a new topic: device controlling using HTTP web server. Uh, in this topic, we will cover up how to connect an embedded device via HTTP web server, and how to control our local equipment or as well as global equipment from the web server. So this is the first slide of embedded system. In this embedded, previously I already talked about the embedded system, what is embedded system, and what are the applications. And in this topic, I'm again covering it with the deep deep dive in the embedded system, a little bit deep dive in the embedded system, and now I'm continuing with an embedded system is a computer system uh, combination of a computer processor, computer memory, and input-output peripheral device that has a dedicated functions with a large mechanical or electrical or electronics hardware and mechanical parts. Because an embedded system typically control physical operation of machines it is embedded within. It often has real-time computing constraints. That means we can do the task as you see your uh, heavy machineries like packaging machines and in the industrial automation, where you can see they are performing some dedicated task with the constant time and with the equivalent speed. So the uh, at that time at the time of operation, they are performing same task repeatedly again and again. So they are much more flexible to do their task with accurately in a perfect manner. And the term of real-time computing constraint means that they are performing the task in real-time system, which means uh, we use the embedded device in the missile system, where we want the high accuracy, so that the with just a nanosecond is a major effect on the missile, so that we will keep in mind that we design that system into according to that uh, according to the that according to that specific features. The next slide is embedded application. The embedded applications are a lot of types. There are some of, I will explain here. The telecommunication system employs numerous embedded system from telephone switches for the network to cell phones at the end user. Computer networking uses dedicated router and network bridges to route
Your voice
data.
is great.
Sorry, sir. Uh, in this application means that we will exchange the data from one network to the another network via the using of router bridges. That are all the example of our embedded devices, where we have to perform the specific task just to move the data or route the data to the specific IP or location, so from source to that to deliver at the destination location. Second one is the consumer electronics, including in consumer electronics, including MP3 player, television sets, mobile phones, video games, consoles, digital camera, GPS receiver, and printers are the example of the consumer electronics, where we can these are the things which are we are dealing with the in our daily lives. So we have to we are also built or modified these uh, application day by day according to our need. And third one is the household appliances, such in this mic in this application, lot of home appliances comes under, such as microwave, oven, washing machines, and dishwasher. These are the basically embedded devices which are doing their specific task. Micro oven is only used for the cooking, in the used in the kitchen for the baking the your food or hot, and just like that. And washing machine is a device which is used to your uh, wash your clothes and drain your clothes. That is doing your specific doing their specific work. Only the washing their clothes, washing your clothes. And dishwasher is the where you can wash your utensils in your dishwasher. And include embedded system to provide flexibility, efficiency, and features. Advanced high voltage AC equipment system and network thermostat is more accurately and efficient controls temperature that can change by time of day and season. In this application comes under the our AC comes under in this uh, in this application, because according to the in when the summer we are using our AC and controlling their temperature from minimum to maximum to minimum, according to our normal life, according to our need or normal life. Home automation uses wired and wireless networking that can be used to control our home lights, climate, security, audio, visual, surveillance, etc. All of which use embedded devices for sensing and controlling purpose. Next is okay, transportation system, from flight to automobile increasingly use embedded system. New airplane contain advanced avionic system as in inertial guidance system and GPS receiver that has considerably safety requirement. In new era, my plane has developed so much so that they have uh, highly accurate. They want highly accuracy because the they are far away from the earth. That is why nothing is there, only the electronic. They are depend upon on the electronic equipment. So the accuracy is the major factor for that, for their driving the plane, and so they need proper GPS locations and guiding system in the plane. Various electronic brushless DC motors, induction motors, and DC motors are used electronic motor controller. We can also control the motor, various types of motor, almost all type of motors, like DC motors, induction motors, stepper motors, from the microcontroller according to our need and application, according to our application. Or now comes the another application: automobile, electric vehicle and hybrid vehicles increasingly use embedded system to maximize efficiency and reduce the pollution. Uh, Other automotive safety system is using embedded system, using anti-braking lock system, which is called ABS, electronics stability control, EC and ESP, transaction control, TCS, and the aut- automatic four-wheel drive. These are the typically well-known terms which, while we are which are seeing in the automobile industry, because the which have anti-brake. We are talking about the anti-brake system, while we have in the uh, going around 50 or 60 kilometer per hour. Suddenly we have to stop, we apply the brakes. Earlier the brakes are drum brakes in the drum brakes are used in the four wheelers. Now braking system is used, embedded is embedded system is using embedded embedded system is used in the anti-braking lock system, so we can stop while we applying the brake without any fraction of second. And now comes to the medical equipment, and use the embedded system for monitoring and various medical imaging, such as PET, SPECT, and CT and MRI. These are well-known familiar terms while we are going to the hospital, where we can see doctor suggest us do this test for the this specific uh, injury, or might have some problem for the any patient. So they suggest to do this test. Just X-ray machine is also the example of the embedded system. Within embedded system within medical equipment are often provided by the industrial computers. These are also called industrial computers because they are using in the medical industry. So these are also called the medical equipments. Now comes to the embedded peripheral. How can we configure the specific doing to do specific task with the microcontroller? How to communicate with another device, and what are the protocols which are falling to you, which are we are to use. So embedded system talk with the others to the outside world via peripherals, just like serial communication interface, which is called SCI, and the protocol name has RS232 and 432 RS485. This is various types of which have various type of connectors, and which have only RxTx and VCC and the ground pin. RxTx for transmitting the data and transmitting the transmitting or receiving the data, and VACC to enable the power supply for the system, and the ground pin for the ground purpose to connect all the device by to start the communication. Synchronous serial communication interface is I2C following I2C protocol, SPI, SSC, and the ESSI, enhanced synchronous serial interface. These are the terms used while we are connecting our microcontroller to the another peripheral, which are used specifically I2C, two-wire communication, SPI is the four-wire communication, SCCI the two-wire communication, and variously we can talk about if we are going too deep in the embedded peripheral. Next is a universal serial bus. Universal serial bus is a USB USB driver bus which has two mainly RxTX and RxTX and BCC ground pin to communicate by the USB driver. This is used you can in the um, PC applications. Multimedia card means your SD card which have storage devices. The SD card is the example of this, and compact flash. Networks we will see the Ethernet, LAN works, and etc. Field bus is CAN bus, LIN bus, Profi, Profibus. This is the protocol used in the automobile industry. Timers, PLL, and capture, compare, and time processing unit. Discrete IO, aka general purpose input output. GPIO, analog to digital converter to ADC to DAC. Debugging for the debugging of the whole system or program by the controller. You can use the JTAG, ISP, BDM port, BitP, and DB9 port. Now comes to the next slide. Here you can see a block diagram of our project. Here we have mainly two devices. One is LED and second one is ESP8266, which plays the as a microcontroller, where we have to control our LED from a Wi-Fi router. We in this scenario we will create our ESP as a web server, and we will control it from our phone, and just we are giving some instruction, just like turn on the LED or turn off the LED, so we can show in I can show you in the next slide. In this in this slide, the various component which I showed you in the last slide, that is one is LED node MCU as a microcontroller or server. Router is I will use my mobile, and which protocol it is following, that is HTTP protocol, and what is the type of server type is local, and if we want email alert, then we will use the Gmail for the transmitting the data to publish on our to my mail via global IP. If we are using a local server, then we can't access to the Gmail. Now, introduction to the hypertext transfer protocol is a standard application layer protocol that function that functions as a request response between the server and client, where we will generate a request to the server, and server respond uh, our request according to the operation which I written in the program. It is widely used in IoT, Internet of Things, embedded application where every sensor is connected to server, and we have access to control them over via internet or without internet if we are using it locally. Node MCU has Wi-Fi functionality available on the board. With the Wi-Fi function, with this Wi-Fi functionality, Node MCU can connect to any Wi-Fi as a client, or it can create a network to which other Wi-Fi enabled devices can connect to it. It can Node MCU has a functionality that it can be also acting as a server or acting as a client. It totally depends upon the application which we want to create. Either it's a server or either it's a client. In next slide, Node MCU, we if we are using a AP mode in the Node MCU, then we will Node MCU Wi-Fi has a access point mode through which it can create a wireless LAN to which any Wi-Fi enabled device can connect. We can set SSID password and for AP mode, which will be used to authenticate the device while connecting it. Here we will use this example for the our application. Here we have to create our Node MCU as a server, where we have to authenticate while we will connect our phone, laptop, or anything Wi-Fi enabled device to connect. We want to connect to that. If we want to use it globally, then we will provide a global IP. If we want to use it local in a local network, then we'll provide a local network. We should follow the all the devices should be in the should be in the same network so that they can connect to local Wi-Fi. Node MCU has a STA mode. What is STA mode? STA has a station mode, using it to connect it connected to the existing Wi-Fi network and can act as an HTTP server with an IP address assigned by the network. Node MCU get IP from the Wi-Fi router to which it is connected. With this IP address, it can act as an HTTP server to which any Wi-Fi device can connect. When we are using the STA mode, the Node MCU will also acting as a server mode while we are connecting our Node MCU to the specific device router which have a Wi-Fi functionality. Then a Wi-Fi router provides the specific IP to the Node MCU, and Node MCU create a node. We can also directly connect to our node or directly connect to the router. We can control the devices through the router or directly to the node MCU. Next slide is for our example. Let's start with the Arduino sketch. We will write down the code with some functionality. So we will follow some rules how to configure our Arduino device, and what are the pins and where we have to connect our things. So HTTP server and Wi-Fi STAAP app mode, and control the LED connect at the server side from the client side. Here we can LED to the pin 2 and the D2 pin in the node MCU board. As you can see in the image below, you can see here in the D2 pin here that is connected to the 330 ohm resistor with the LED, and the LED's next terminal, another terminal is to ground. If we are directly connect our LED to the D2 and ground, we will have some negligible effect that like we burn our LED, and so to minimize that effect, we will use the uh, register for that purpose. HTML client, HTML page for client, an HTML server for LED or on-off functionality. We are going to make a simple HTML page that will be visible at the client side and able to take user input or for LED on or off. It is a user-friendly representation of button input that takes input from the user to click. We need to write the two HTML code, for one is for LED on and one is for LED off, such that when a client click on LED on, the action should perform LED should be on, and the another one is LED off. In the next slide, I will show you the example code of HTML for which we have write down for the HTML. Here we will start the HTML body for the web page, header and title, set LED control, and this is the title of the body, title of the web page, and then its body and body started for LED, then para, started the para, click to switch LED on or off, on and off, para, and from method, from which method it is get method or post method. In next is input type, button, that is button, we are using a button for the input type, and value is LED on, and what is the action? On click. When the on click, window dot location dot href for the LED on, it refer to the location from where the code get connected to the root page of the code. Here form and body and HTML page. Next, same for the LED off. Here you can see LED, only the LED off is changed. Another things are same. Now the details of the HTML lines. What is the meaning of doc type HTML? This declaration defines that the document as an HTML that helps browser to display web page correctly. It must only appear once at the top of the page. It will show only a once time. And what is the role of HTML? The element is the root element of the HTML page. Next is head. The element contain meta information about the document. Next is title. This element specify a title for the document. Next is body. The element contain the visible page, contain content such that body of document. H1. This element defines the largest font size of heading. Similarly, we can use H2, H3, and so on. Smaller, smaller font size for the header. And P1 element defines a paragraph form. The element define a form that is used to collect user input. And the location, the window.location.href, this is the property that will tell us the correct URL location. Changing the value of the property will redirect the page. So we will configure right now our application according to the that scenario, and how to write our code. And now we will see these are the following parameter we will set into our code for the in this Wi-Fi access point mode node MCU create a server. Hence we can set it uh, its IP and subnet mask IP gateway. So we will so that only we will know what is the IP and the only the security purpose for the local network. Otherwise, anyone can access if we are doing it openly. So we will use our HTML code for LED on off, and use this uh, credential for node MCU for a security purpose. Mm, this is the program which is we have to write into the our Arduino IDE. Firstly, we have to define two libraries. From one is for Wi-Fi.h, and another one is for Wi-Fi ESP8266 web server.h. So in this program, Wi-Fi.h for Node MCU is the compulsory library, and if we are creating an AP or STA mode, we will have to write down this second library. And now we will use our credential to set in our code. We will do as same. Constant char SSID password, set the password here, and local IP address, just like local address, local IP address gateway, IP address subnet mask, ESP web server at local port 80. Now, next is how to set a pin. This is the method to set up pin D2. Initially, we will status the give the status to the D2 pin or LED to low. That means initially it goes off. Initially it's off, and while we define some setup in the void setup, serial we will begin a serial monitor at baud rate 9600. Pin mode, we will define pin mode for the which type of the device is connected with the node MCU. Is it a sensor or is it a LED? For LED, LED is the output device, so we will mention here as an output device. If we are connecting a sensor, then we will define it as a input device. Next is our setup our call our SSID password, and then our AP mode local IP gateway that defines above in the code. Uh, then provide some delay for the setting up properly. Then we will create some function server dot on handle on connect server dot on LED on handle LED on server dot on LED off handle off LED off. Next is server dot on not found. If we did not found anything, server begin initialize the server, and this is the serial print for the serial monitor to know how is it server started or not. Then comes to the void loop. This is the main loop, just like a normal microcontroller code. Any of microcontroller, we set up the main function. This is the main function of the uh, Arduino IDE. So here we have to define our whole things. Server handle dot client function, we will call this function, and if LED status digital write pin high, as what is the status, it will show the high or low according to that. This is the function which I created, handle on connector. What will happen when it is on? LED initially of status low, and server send 200, which means connected successfully. Text HTML send HTML false. This will goes to the false notification, and handle LED on, then it will connect is to hide the LED, means turn on the LED, and similar for the LED of status will be low, and the send to the false. And this is the void handle not found. If we did not found anything, or maybe server request is not responding, then we will raise an error 404, plain text in plain method of plain text not found, LED not found, or my something like this is the send HTML code, where we have to write some create our page string similar we see in the HTML code. This is the uh, function where we have to write the whole code. String ptr and a lot of other things all are defined earlier. I explained you, and this is the uh, both the function for LED on and LED off is put in this function, and according to that we will perform the action. This is the after that uploading the sketch uh, into our microcontroller, then we will connect to the network created by the net node MCU. And after connecting Wi-Fi server in the browser, or maybe your mobile phone, if it is in the same network, then we will connected to at the same IP which I mentioned, which we will mentioned in the code. The you will see in the web panel. This is the view of your web panel. If we click on this LED button, this it will turn on the LED, and here slash it goes to the request to the node MCU server, and node MCU will perform according to that which request is occur the at the end of node MCU. Is it on or is it off? The slash status will show on the end of at the end of the IP address. Is it on or off? So now I will share my screen where all thing is happening. This is the code. As I explained in the PPT, you can see same, all are same things I written in this code. Nothing is changed. If I set up it, this is the last part which I explained. This will create our web page.
Icona? Hello?
ಹಲೋ
This
ಏನು
this
ಮಾತಾಡು
ಈ ಕ್ಲಾಸ್ ಇದೆಲ್ಲ ಆಮೇಲೆ ಮಾಡ್ತೀನಿ
ಸೈಕೋನ ಕಾಲ್ ಮಾಡ್ಬಿಟ್ಟು ಮೇಲೆ
and
ಕಟ್ ಮಾಡ್ಬಿಟ್ಟು ನಥಿಂಗ್ ಅಂತೆ
ಹ್ಮ್
now we will use to
ನಾವೇ
connect
ಬರಕ್ಕಾಗಲ್ಲ
our
ಕೇಳ್ಬೇಕಾ
node MCU. How to connect our node MCU firstly comes into the mind. This is the tool. Select your board, which type of board you are connecting. Here are lots of board. You have to select Arduino, Uno, Mega, Lorin, etc. Here is the node MCU ports which supported the Wi-Fi
ಇಲ್ಲ
functionality.
ಆಗಲ್ಲ
Four types of
ಒಂದು ನಿಮಿಷ
boards are here. You have to select which type of your board. I'm selecting Node MCU 0.9 ESP12 module, and according to that, it is set, and now it is configuring, and now these all are values according to which uh, which speed I want to which I want speed or baud rate which I want to upload my program. What is the frequency of the node MCU should be set, but what is the flash memory of the node MCU, debugging port is disabled or serially enabled, debug level. There are various level of node MCU you can wish to use as your development need. Look, LWIFP variant. What is the variant of your? Is it band, Bluetooth mode or not? And B-table flash, heap, RAM, and a lot of other. If we only sketch erase type, only sketch, we want to wash our only sketch or sketch plus Wi-Fi settings plus or all content, we will select our need. And then this is the security based SSL, and this is the port where we have to connect our port, where we have to connect which port, at which port our node MCU is connected. So we will only select two uh, only two options here. One is select your node MCU, then you will select your port rate, port, only port. Then rest of things you will remaining the same because it doesn't affect so much on your node MCU. So I'm here uploading this sketch into my node MCU. As you can see, here is uploading. It will take some time to upload because it is a small device, so it will take to configure. Here are the details how much code is uploading into Node MCU.
This conference will now be recorded. Muted.
Now we will
Unmuted.
here you can see server is started and are you able to see my phone screen? Hello? Hello?
Yes,
Yes, sir. We can able to see.
Okay. At this moment, the LED is off, and right now I'm configuring my phone.
anybody want to say something?
Sir, actually, one doubt. Is there any other device like MC Note?
Sorry, sir. Can you repeat?
Is there any other module is there like MC Note?
Sir,
Is there any
there
other
are
model?
lot of version of Node MCU. It is it is the Lolin based, and one is Atom based, and another one is ESP32 that has inbuilt BLE technology, and another one is ESP01 that is has only uh, Wi-Fi, nothing the pin module just to configure. That is we will configure self configure.